So you got to know what those are, otherwise the formula is useless, right? Good. Number of sides. So remember, n is number of sides. Okay. This shape has how many sides? 11. So you can plug in 11 in there. That's how many sides. And then what does S stand for in this formula? What are you calculating? Sum of what? So S for sum of what? Sum of the interior angles. Yeah, sum of the interior angles. So this formula works for the interior. What's the sum of the exterior angles? Always 360. Good. Natalie didn't get tripped up with that question. So we don't really need a formula for the exterior. We just know, oh, it's always 360, right? So don't forget that. We talked about that already. I'm trying to drill it into your head. The sum of the interior angles, you need this formula for it. Good. So you go ahead and calculate that. S is 1,620, right? Good. Okay. And we briefly talked about this, but I'm going to bring it up again just because this is an important word. It's just one little word, but it means a lot in geometry. Regular. Okay, regular. Oh, did I change? I've barely talked about it. But it means that all angles are equal and all sides are equal. Now the sides, that part doesn't really help us too much on this question, but it's good to know. Yes, very good job. All the angles being the same, that is important for us to know, right? So if we know 1,620 is the sum, how do we find one interior angle? We'll just call that I. Correction, Sally. So if we know that the total of all 11 angles is 1,620, and we see that word regular, that means all 11 are equal. So I can divide that by 11 and be confident that all 11 of those are equal. Okay? Does that make sense? So FYI, I'm asking because this will be on your test. Okay? And again, it says round to the nearest tenth, so I'm going to put 27 in here. What would I round to? Good. I'm saying yes, 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 yes. What would I round to? So 147.27. Okay, so let's go with Dax. Dax says 5 and above, give it a shove. 4 or below stays down low. What number are we looking at, though, to see if it's 5 or above? Can you guys grab your pointer hands and point to it? What number am I going to look at? I want to see 31 pointer hands up there. What number am I going to look at? So 2 is in the 10th spot, but that's not the number I want to look at to decide on rounding. So which number am I going to look at to decide on rounding? There, I see it moving over a little bit to the right there. Yeah, you're going to look at that 7 that's all the way to the right. Good. So you're going to look at that 7. Since it's 5 or above, we're going to give the 2 a shove, right? We're going to boost that up to 147.3 degrees. So like I said, that was only the warm up, but we've already reviewed some important stuff for the Unit 1 test. And so that's our focus today, is we're going to go over the 1.16 test. So today on your schedule, already leave. Okay, yep, Natalie's here. And this is true for any of them. So here are some of the things that we talked about in Unit 1. Points, lines, planes, angles, lines of symmetry, all about those transformations, the 4 different types, right? Translations, reflections, rotations, dilations, and then taking the points and being able to figure out what happened there. Is that a transformation? Is that a rotation? Yeah, I'll try to leave some class time, Preston, so you can get that done. Yep. That's a good question. And you guys are more than welcome to look at it like earlier on Wednesday and try it. And, you know, then come to class, like don't turn it in yet, come to class, review it, see if like, oh, okay, I was on the right track, but I need to fix this or that. You can do that too, just to kind of have an idea of what it's about before you come to class. Okay, first I'm going to actually go to this page on dilation. So last Friday, you should have taken a quiz on dilations. It was lesson 1.14. And looking back at the scores, it looks like you did really well overall. Although some of you haven't taken it yet. So for those of you that haven't taken it, I'm not sure if you're hesitating because you're like, oh, I didn't quite understand that. So I thought let's cover dilations first because we haven't really talked about that together yet. Okay. So here's a picture of a dilation and a type, similar question that you might get either on that 1.14 quiz or on the test. So can somebody just read this question to me on the mic? You don't have to do the question. You certainly can if you want to, but just read it. Somebody hop on the mic and read it for me. Okay, Benny, thanks. Go for it.
Can you guys hear me?
I can.
Okay. Trapezoid W prime, X prime, Y prime, Z prime is the image of trapezoid W, X, Y, Z under a dilation through point C. What scale factor was used in the dilation?
Perfect. Thank you. I love to hear your voices. Perfect. Okay, thanks, Lonnie. Yes, that's okay, Natalie. Yeah. Thanks, Benny. I appreciate that very much. Okay, so what does, when Benny read it, if you guys noticed, it was W prime, X prime, Y prime, Z prime, right? What does that mean in geometry? What are those little apostrophes? We call them prime, but what does that mean? You too, Natalie. The new image, right. Or we call that the image, right? What do we call where you start? Good, Omar. Yeah, so this is the image. Good. Where we start is the pre-image. So WXYZ is the pre-image. So look at the picture. Can you guys tell me, is the pre-image larger or smaller than the image? Yeah, Preston, do you want to get on the mic? I would love that.
Okay. So, I would recommend zooming in for this just so you can get a better look.
Ooh, that's good.
Helps a bit.
Yeah, those plus and minus symbols on the right side of your screen, guys.
If you look closely, you can see that the prime on the image is actually smaller than the pre-image, which means it shrunk down. And we can also see that it did not flip sides as well. If it was a negative, I'm gonna actually put my pointer hand here. If it was a negative, like one of these, that would mean that this image here would have to be flipped upside down, the opposite of this, because of how that works out. And why it's this instead of this is because this is bigger than 1, which means it would have grown. This is smaller than 1, which means it shrinks. So since we know that it's shrinking and that it hasn't flipped, we can go by that and find out that it is 5/6.
Very nice, Preston. Awesome. Excellent explanation. Yeah. So the other thing that I would add too, you're totally right. If it was negative, it would have flipped. The other thing is that it would be on the other side of the point of dilation. So that's also what the negative means. Yeah, very good explanation. So see how it says we're dilating through point C? Point C is right there on the picture. If you kind of imagine, I like to draw a line kind of like act as though that was my mirror. So both of the trapezoids are on the same side, right? So we say same side of point C. These are both on the same side. So that means that your dilation amount should be positive. So like Preston said, it also would mean this image would get flipped over, because what will happen if it was over here on the other side of the red line, it would end up being reflected, but also it would be on the other side of this line. So the negative in a dilation doesn't have anything. It's not like a traditional, number scale. It doesn't mean that the negative 6/5 is down in the negative number line. The negative has to do with, is it on the same side of the center of dilation or on different sides? Okay, so positive means it's on the same side, negative means it's on opposite sides. So, and then like Preston said, you can just look, if you have multiple choice, just look and say, okay, well, I know it's going to be positive because it's on the same side of the center, so I can cross those off. You can convert these to fractions or mixed numbers, so this would be 1 1/5. That's larger than 1, which means your image would be bigger. And we don't see that. We see that it's smaller. If you didn't have multiple choice, what you would do to get that fraction is you would take the numbers, find some numbers, matching numbers. So we see on this picture 18 and 15. So make two fractions. You could do 18 over 15 or 15 over 18. And then ask yourself, which one of those is going to make it shrink down? Which one of those is going to be smaller than 1? So right here, if your image is getting smaller, you want to pick the fraction that's smaller than 1, okay? Which would be the 15/18, or if you reduce that, you get that 5/6. Do you guys remember how to reduce that fraction? Okay, thanks, Colvin. How are you guys feeling about this page overall? This is one of the trickier things in Unit 1. So be honest with me. As a side note, if you guys missed small group this morning, I know Dax was there, a few others of you. You can back me up. We went over some more of these types of questions, 1.14. So that would be another thing if you guys are kind of like, And I only see 15 out of 29 of you guys letting me know one way or the other. So let me know. It's okay if you need to give me a frown face, give me a frown face. I'm just kind of gauging, how do you guys feel for the most part about these dilations? Okay. Awesome, Colvin. Thanks for letting me know. I was just asking how you guys are feeling about dilations, if you see that polling up on your screen. Okay, so it looks like the majority is okay, and then there's like half of you guys are like, I'm not sure yet. Okay, so what I would say, one thing I forgot to mention, today's scheduled for your test review. There's not really a formal test review, like where you can go in and practice. What I would suggest is go back and look at your quizzes. There's always a review button for every single quiz, and you can look and see which questions you missed. So if you take the 1.14 quiz, you still have 3 chances on it. So if you take it once and you don't do well, hopefully this will help you. Give it another try, see how you do. But just in terms of a test review, go back and review your quizzes. That's a good way to review, because the test questions will be similar. And then, like I said, we went over the 1.14. So that question that we just went over, we went over some other ones like that during small group, and the recording is posted for that. Okay. Alrighty, let's take a look at this. Can I have 4 volunteers? And if you're not totally sure and confident that you know how to do this, that's a perfect time to volunteer. I know you guys tend to be scared. You don't want to. Okay, go ahead and raise your hand. So Emma, take the first one. Dax, take the second one. So let's do Emma, Dax, Who else? Okay, awesome. You guys are awesome. Okay, I'll do Jason and Luke. Thank you, Logan and Preston. I will catch you guys on the next ones. So Luke and then Jason. Okay. Can you guys hop on the mic and tell me maybe how you're right, Emma, that first one's translation. Very nice. Like, can you describe what you were thinking when you figured out it was translation? Okay, Emma, that sounds good. Okay. Yep, that's the second one. Good. So nice, Dax. That is a reflection. Awesome. Go for it, Dax.
Okay, can you hear me?
I can.
Okay, so it's a reflection because it's literally just getting it and pasting it on the other side of that line.
Good. And yeah, I appreciate you drawing that line in there. That's like your mirror, right? So that helps us to visualize that. Okay, and Emma's describing that first one. She's saying she thought translation because it's the same shape, same size, same shape, just moved to the side, not upside down or nothing. That's right, or nothing, Emma. But you're right. Another way too, because I think the ones that get a little tricky are rotations. What one thing I suggest with translations that helps me, these are, like I said, they're a little easier to see, but if you connect all the matching points from the pre-image to the image, see how it almost makes like a wedge of cheese or like a 3D shape? Those blue lines that I drew in there are all parallel and they're all the same length. So that's a good hint that it's a translation. If we look at the one that Dax did and explained so well, we can connect the matching points and they're not all the same length, but I love how you drew that line in there, Dax. You can see from that line to the T and that line to T prime that those are all the same length. And so that is a hint that it's a reflection. So like from your line of reflection to point R or your line of reflection to R prime, if those are the same, that's a good hint it's a reflection, okay? Oh, Preston drew the line. Okay, thanks for giving credit where credit's due, Dax, but yeah, I appreciate that. I know, I'm hungry, right, Caitlin? We're talking about cake and frosting. Now I'm seeing cheese on the screen. Oh, oh, I love Parmesan. Any kind of cheese. I'm a cheese fan. Okay, so Luke, what did you say for yours? I see a dot right there. I'm not sure if that's in the right spot though. I think you had typed it in the chat. Rotation. Okay. Yep, that is correct. Let's move that. I don't know. Oh, that was Preston's dot, but I'll move it over there. Yep, rotation. Okay, so if you kind of do that same technique, do you want to explain how you saw it as a reflection, Luke?
The dot was there to be the point center of rotation.
Oh,
it was supposed to be a hint.
Gotcha. I love that. Nice. Let's put that back.
Just like the line.
Yeah, I love that. Very nice. Very nice, Preston. Yeah. Okay. Well, yeah, it is flipped, but it's almost more turned. And I really like how Preston clarified that for me, because here's what you can visualize is connect your matching coordinates, and the point of rotation is going to be where those all cross. So that's kind of how Preston visualized that dot there, and you got it really accurately. Very nice. The other thing too is you can see those lines. This is a really technical way to get this. If the lines are just all mismatched and there's no pattern to it, like the translation and the reflection, that's a good hint that it's a rotation. But if they are all crossing, do what Preston did and look and see, okay, if I turn it, Like if I put, remember how we talked about those brads? You stick your brad right there and you twist this in a circular motion. If I twist them all in the same amount on the circle, would they all end up, you know, like from R to R prime? Then that's a rotation. Okay. And good. Jason got the last one, translation. Do you want to tell us how you visualized that one, Jason? And sometimes it could be kind of hard to describe, but go for it.
Alright, I figured it was translation because of his reflection. The two eyes would be closer than they are right now. Plus, I guess if you're going on what the first one did, if you were to draw lines from S to S, R to R, and whatever the last letter is, to be the exact same.
Very nice. Excellent. You guys are on top of these. Both of those explanations were great. Yeah, you can connect those, but I like how you thought of it as the distance would be different if it was a rotation or a reflection. Yeah, nice. Very good. Very good, guys. How are you guys feeling about this page overall? Use your polling there. Good. I'm seeing not everyone's answered yet, so there's 28 of you guys in here. I want everybody to answer. You can be totally honest with me. Be totally honest with me. These can be tricky. Some of you guys can visually see these easily, and others of you just have a really hard time with this. So if you're in that category, you're not alone. Lonnie told me she was away. Keaton, how are you feeling? Declan, how are you feeling about it? Okay, this one's looking better. Looks like you guys are having a little easier time for the most part on these than the dilations. And that's understandable. We just barely got to the dilations. So keep practicing with those. Should get easier. All right, now that last page was a little easier than this. This still has to do with transformations. On this one, though, we have a sequence of transformations, which means that you're going to have at least 2 different transformations. So on the graph, no, okay, so now when you get your test or your quiz, you don't see this here. So like, let's cover this up, okay? That all you see is the wording. So I would highly recommend, lots of red, yes. I would highly recommend, like I said already, definitely have paper when you're taking the test, even if it's a computer graded one. But in addition, I would have graph paper. If you guys need graph paper, I do have some in the resources folder. Ooh, Vinny and Amari, really into the red. And so I sketched the pre-image and the image, all right? Yeah, and those blue fans, I sketched the image in blue, okay? So what do you guys think compared to, when I had this covered up in red versus having the graph? Yeah, okay. I think so too. At least, you don't have to do it if you can figure this out. Just using that link, actually, by the way, let me share this with you. So again, I've shared this a few times. Hopefully you guys already have the link, but it is in the resources folder. That's the link to the rules. So you could play around with those and just try to go from D to D prime. But that might be a little bit challenging. So if you find that's challenging and you're not able to get the answer, graph it, okay? Get a picture going, see if that helps. So what do you guys see? What do you think? We have to put 2 of these, A, B, C, or D. So A, B, C, or D here, and A, B, C, or D here in blank 2. So what are some guesses? What do you think might have happened first? Let's try. What do you think might go in blank 1? What's the first thing that could have happened to get from the red triangle to the blue triangle? Okay, reflect. Let's see, I only see C is the reflection, right? So reflect across the y-axis. Okay, let's try it. If I reflect across the y-axis, that means I'm going to take each of my points and go this way, the same amount on the other side. So kind of drawing an arrow to show. This one's going to overlap that one. Okay, so I end up with that green triangle. All right, so let's put C here. Okay, and then Caden's saying then A. So then take that green triangle and move it to the right by 2. Do you guys think that looks like it's gonna work out? Okay, Preston agrees, Luke agrees, Dax agrees. Okay, you guys actually had that earlier. Yep, I think that looks good. Now again, some of you guys can see this quickly and easily. Some of you have a harder time with this, and that's normal, all right? So it is C and then A. If you guys remember last time I told you, you can't break these, okay? Like you can get more graph paper if you need it. Play around with it. Some of you guys were able to see that you do reflection across the y-axis and then translation 2 units right. Let's say you're not sure, just pick one and try it. Start with the red triangle, translate it 2 units up. See where that puts you and then say, maybe let's try a rotation of 180. Let's see if that works. And see where it ends up. If that's not it, try again. Okay, now it's always good, that's why I suggest to draw the picture, because usually, at least if you can get one of them, one out of the 2, it'll speed things up, right? Yeah, that's a great idea, Benny. You could cut out a triangle and put it on a graph and play around with it. That would be a great idea. But these take practice, and like I said, you just kind of have to play around with them. So just apply these different strategies. Is there a combination here that would also work? Did anybody find a second way to do it? I hadn't thought about that. Sometimes there is, though. Sometimes there's more than one way. I wonder if you could do translation 2 units up. I don't think that would work. I was going to say then rotate 180. Maybe if there was a rotation of 90. B and A, B and then A. So if we rotate it, let's see. Just for reminding ourselves what rotation of 180, if we connect, green, if we connect this point through the origin and extend our line straight out, that point would end up right here. And then if we did A and brought it two to the right, it would end up there. It doesn't quite, if it said 2 down, if one of them said 2 down, it might work. I still think that would be upside down though. So I think that's the only combination. On the test, there should just be, I think there's only one answer. So that's the good news, but. Okay. All right, can I have 4 volunteers for this one? I want everybody to take one of these. Awesome, Preston. Okay. I love it. Okay, so I'll put Preston down for this first one. So Preston, what I'd like you to do, since you have the first one, is take point A over here and show me what this rule would do to point A. Okay, and I need 3 more volunteers. Now, on the test, or the
So should I start doing this now?
Yeah, go ahead, Preston.
Okay. Could I have like the
Oh,
pointer finger?
Yeah. Yep. There you go. Sorry about that. Okay, so let's have Dax do the second one. And Kaden. So Dax, take point B and just show me on the graph what it would look like. You can give me your answer here too. But what I'd like you guys to do, this is extra. So what I was going to say is that when you see this question, you won't see this graph. You won't see point A, B, C, and D. This is just a strategy that I'm adding on here to help you guys with these questions if you're having a hard time with them. Some of you guys might not need this, okay? You might only need that rule sheet. But if you're finding that you have a hard time with this, or if you're like me and you're a highly visual learner, I like to graph it and see what happens when I apply this, and that helps me come down here and select the right answer. So if I start with point A, Preston's going to take point A, and I just made this up, okay? I totally just randomly put a dot there. So you can get a graph, piece of graph paper, pick any point anywhere, and apply this rule to it and see what happens. Oh, by the way, try to choose, I mean, definitely label it with the prime so that we know it changed, but maybe try a different color too. That way you guys can more easily see that it was something you guys did. And then Dax, you can take point B and apply this rule. Looks like Caden's already, you guys are on it. Awesome. Can I have somebody take the last one, point D? Callista, will you try it? And again, guys, if you're not totally sure, that's okay. That's what this class is for, right? It is not, if you already knew everything, you wouldn't need to come take the class, right? So the point of class is to try it. I'm here to help you with it. If you make a mistake, that is totally awesome. Because actually, when you make a mistake in here, you're going to remember not to do it on the test, right? And that's where it really counts. All right, so Callista, I'll put you on this last one, okay? If you're not sure, just let me know. I can help you out with it. All right, let's see. So let me look at Caden's first. That looks good. So Caden's, the XY is the original point. So this is where Caden started out because he's doing point C. X minus 4 means you're going to move it, let's see, 1, 2, 3, 4 left. Okay. Do you think that helps you guys? What would you, I know we're kind of out of order, but what would you guys say number 3, what the answer would be based on the graph? Hopefully that helps a little bit. So if we took point C and it moved over here, now come down here and read the answer choices. What would you say? And then let's see, Dax, this is B. Is it B prime, right? B prime. All right, and Preston correctly applied that. Good. Can you describe, Preston, on yours, how you knew it was over here? I think a lot of times this is confusing. What does this negative x mean? Can you describe that?
Yeah, so negative x means that you take the previous x value, which on this was a 6. I counted through the lines and saw it. There's 6 lines until you get to A. So x in this is 6. In this, that means that y would stay the same. Y is 5. So yeah.
Okay.
But in this, you take that and you apply the exact rule here. You just make 6 negative.
Good.
And leave it the same, and then you got it. Just reflecting across the y-axis, and you can see that because this is the y-axis right here, and as you can see, it just gets flipped over it.
Very nice. Good. Excellent explanation. Very nice. Do you guys see that? Does that make sense for point A? How it's just reflected across the y-axis. That's what Preston chose. Good, good. Okay, good.
Who was drawing the coordinates as I was talking? Was that you or?
Oh, yeah, it was me.
Okay. If that was somebody else doing it, I want to thank them for that.
Oh,
So,
gotcha.
yeah,
That
I
was
just
nice
wanted
of you.
to know who it was
I
because it was nice. So it was a reference.
Yes, yeah, that's what I was hoping. I was kind of. I know it's hard to talk and write at the same time when you get, especially with your mouse. It's not the easiest. So I was trying to add to your explanation, but that was great. Okay. So yeah, DAXs is similar idea. I think Dax and Caden, they're somewhat easier because you don't have to. It's a little more clear maybe on what you do. For example, if we find the coordinates for B, what did you get as the coordinate for B, Dax? Or do you want to hop on the mic?
Hop on the mic. I didn't actually find out the coordinates. I was in the middle of counting.
Oh, gotcha. Yeah, and see, that's the other benefit of the graph, right? You don't even have to really know the coordinates, but that's great. You knew y minus 4 meant go down 4, right? So that's great as well. 1, 2, 3, 4, 5, 6. So I think it's negative. Yes, lined up with A. So -6, 2. And then this B prime is -6, -2. So thanks for doing that, Dax. You guys can see, I'll try to highlight it. It's a little bit hard to see, but there's a difference of 4. Okay, thanks, Amy. If you subtract 4, 2 minus 4 gets you to that -2. Okay. All right, what about that last one? Can somebody take that last one?
Could I quickly say something?
Oh, sure.
I just want to say, technically, with how B is, the second one, it could also be a reflection across the x-axis for this, just because of the position. It wouldn't, but because of the numbers and how it goes, it could be 40 units down or a reflection across the x-axis.
Yes, good point. That's absolutely right, Preston. Yeah, there could be 2 possible answers there. Yeah. Great observation. Very nice. I guess the only, yeah, and I guess on the test, you would want to go with DAXs just because right here, it specifically tells you what's going on with the coordinate. But you're totally right from the graph. If we were just going purely off of the graph, we could have also said reflection across the x-axis. Okay, yeah, take the last one for us, Dax. I appreciate that. We're almost out of time. This class always goes by so quickly. I think the last one's a little bit trickier.
Okay. So D is just another reflection across the y-axis. It just ends up landing on the same point, just on the other side of the graph.
Well, almost. It's actually not just across the y-axis, though. I think I see what you're saying, but are you thinking that D is going to end up like somewhere over here? Or do you mean like over here?
No, the top one, my bad.
Yeah. Yeah. No, you're totally right. So you're right, it is reflected. Not just, so if it was just across the y, it would be over here in quadrant 3. Or if it was just the x, it would be up here in quadrant 1. So it's kind of like this one got reflected across the y and then across the x. That's one way to think of it. Or 180. So like if you can picture a diagonal line, like right here, that if it gets reflected across that line, so D would be over here. Or D prime would be over here. That's a reflection across rotation of 180. So that one's a little trickier. Okay, yep, we are done, but I hope